Alright. Okay. Hardest thing I've done all day was balancing my phone to actually be able to see the screen. But today, I'm going to show you how to solve an ideal op amp. The reason we know it's an ideal op amp is because it has this feedback loop. Feedback loop. And it doesn't have two little thingies right here. The gain and all that. It doesn't have that. So, it's ideal. D-E-A-L. Yay. And what that means is that B plus is equal to B minus. So first what we're going to do, we're going to solve it in two parts. The first part is going to be this bottom loop right here. I don't want to draw through it. So it's still straight, cool. Bottom. And I'm just going to draw the branch by itself. So that circle. Right, so this is V plus, this is V2, this is R3, there's R2, and this is ground. I'm not going to write that in there though. So the way we're going to handle this is we're just going to do it from node to node. So we're going to go from V plus and from V2. I'm ignoring ground because it goes from 0 and then it changes to V2 and it doesn't really matter. So this is going to do, we're going to do V2 minus V plus, then parentheses. And we're going to divide it by the total resistance of everything it crosses. So since they're in series, R3 plus R2, and that's going to be equal to 0. So that's our equation for the bottom half. And we're trying to get it so we can simplify everything and do it in, terms of V plus and V minus. So we're going to break this up. And for simplicity's sake, I'm going to say that R3 plus R2 equals R4. So I'm going to have V2 over, minus V plus over R4 equals 0. And that can be broken up into V2 over R4 minus V plus over R4 still equals 0. We can move this term to the other side. So V2 over R4 equals V plus over R4. And they both have R4 on the bottom, so we can multiply both sides by R4. Gets rid of that. And what we're left with is V2 equals V plus. So that's all we need for the bottom half. I'm going to erase this. So if you want that, you can back it up and find it. I'll write this at the top so we have it. V2 equals, I'm going to write it over the side actually. So V2 equals V plus, so as one equation, simplified and beautiful. And then from there, we're going to handle the top half. So do it right here, top. And the top half is going to be literally this giant chunk. It's not as complicated as it might look. So we're going to have ground. I'm starting from this side. You still see? Cool. And we're going to go to this voltage source and a resistor and a node, that's this one right here, and a resistor and another node, which is V out. I'm going to label everything. So V out, R1, R1, V minus is V1 plus minus. And that's what our top half looks like. So that's everything up there. And so we're going to do the same thing we did for the bottom. We're going to do this node to this voltage source. We're going to have V1 minus V minus over R1 equals this side, which is V minus minus V out over R1. And already we can see there's R1 on the bottom of both sides. So we can multiply both by R1. Let's squeeze this in the bottom. So here's my line. Multiply everything by R1. We're going to have V1 minus V minus equals V minus minus V out. And I'm going to take, that's not a fraction, don't get it mixed up. Take that up here, and I'm going to move this term over to this side. So I'm going to have V1 minus 2V minus equals negative V out. I'm going to just leave it as an L for now. So from there, what we're going to do is we're going to take this, we're going to plug it back in. So V1 minus 2 V2 is going to be equal to negative V out. And then we want positive V out, so we're going to just flip the signs on everything. So V out is going to equal 2V2 minus V1. And that is it. That is our answer. Yay! Woo. Now there are more complicated versions, and I'll do one of those in another video, but this is just a mostly simple ideal op amp.